Hello and welcome to another episode of Getting into Good Oxide. Welcome back, Sydney.
Hello, hello.
And today, we're kind of brainstorming still what we should do next because, well, the overview is there, but now at some point, I guess we should dive into actual code, just try things out. Like how do you use Good Oxide? So if you were to choose a crate to look at first, which one would that be based on the knowledge you have?
Based on the knowledge I have, I know you kept talking about, Git repository that kind of brings it all together. So I'm not sure if that should be the first one or if you want to dive into something more specific at the beginning.
Yeah, you're right. Git repository has everything, but also it's kind of the all-in-one kind of thing. I do intend it to be the entry point. So ideally, that's the thing you use, and that's the thing that gives you everything you ever want quite easily. That's supposed to be the most comfortable to use, whereas all the other crates, especially if they go down to plumbing, they might be harder to use, especially right now, even though I'm working on changing that a little. But, you know, so from that point of view, Git repository should be the nicest to use and also fast. So it's not that this is slower or something because it has some nicer API on top. Should all be pretty free in terms of cost. So yes, maybe that's the one to go into first, because from there we can use other crates implementation. Also, that's the one you would use if you want to use Git Oxide in your own project. That's the plan, because really you don't want to get into plumbing. It's too low level, it's too uncomfortable, especially compared to libgit2. Because if you have to write 3 lines where libgit2 takes 1, yeah, I think comfort is a big selling point as well. All right, then let's try to do something comfortably. I thought, why not use the Git Oxide project itself and just make an example. Like, how do you do certain things? Everything. Oh no, maybe stats. Stats RS, because stats would allow us to just collect data and print it out in some way, which seems like a good starting point. So we don't really change things yet, just read only access to the repository. And we can see what we can do with that. So stats is here. It's not included in the module tree. That's interesting. Did I get something wrong? Because it should be picked up automatically here. But maybe we just put it into the actual crate. Are you telling me that this already has an examples directory? Yes, it does. Okay, cool. Yeah, I think that's used in testing here, this example. But now we add another real one. Okay, there we go. Now, let's try that again in Git repository. And it picks it up. Sure, why type something ourselves when IntelliJ can do that for us? Let's run it right away. IntelliJ can do that too, I think, like this, and we should have this option here, run stats, and I will bring the window over here, and we'll reduce our pictures a little. Okay. Oh, that's the build information. Actually, we want the run window. Here's that. Okay, cool.
That's actually a nice little, like just actually realizing what's happening here, because at the beginning I also just threw files into the file structure, and then it always complained that it wasn't linked correctly. And there is a very specific thing that you have to follow with Rust, right? It either has to be in this whole module tree system, or like we just did now with the examples folder, it just magically works in there.
Yeah, it's actually a nice, honestly, that's something I want to learn from as well. It's having defaults that you can modify. So if you know the standard structure, you just put stuff in there and it always works, which also kind of unifies how projects look like. But if you need anything special, Cargo Toml allows you to change everything and configure everything the way you want. But yeah, so I really like this duality of things. Hello world. Okay, so I guess we should start instantiating a Git repository. Oh yeah, by the way, first of all, we have to use it. Of course, yeah, let's just start with getting most directly to it. Git repository and then discover. And I think there's also open. So these two top level functions you can use to get started. And this actually sounds pretty good. Some path. Let's give it just the current working directory. And then we could maybe print something that tells us which repository we are working on. Repository, which one is that? It's repo. Oh yeah, right. That's actually, makes sense. That's actually a result here, huh? Of course, because a lot of things can go wrong. For now, I just unwrap, or maybe I'm able to do something like this. Box, then std error. Does that work? So it automatically converts whatever this is into a box, and that should work for every kind of error. So what about now? That's better. Let's print the working tree, or else the oh, come on, the git dir, because not every repository has a working tree, a work tree. The work tree is the thing that has your files checked out, but bare repositories, for example, they don't have that. Actually unwrap or like this, and then display, because it's a path. And the work tree, sure, that's an option, as ref. So now we should get closer to this. What's your problem now? That's a path. This should also, yeah, right, as dref. Okay. Yeah, that was easy, wasn't it? All right. Sorry. Sometimes I'm just, but maybe stupid me is kind of doing what's intuitive sometimes. Like I only care about the error now, so I put a box doing error, but it's not really it, right? So now we are there. So that's interesting, huh? Like even in terms of Rust, like the things you do to do this, but also it forces you to handle that there is not always a work tree. And how you can just in one line handle this without having any if statements or something like that. And that's pretty nice. But also you kind of have to know a lot to make that happen. Because you have to know the types that they expect. You have to know that sdref is dereferencing a path buffer. And a path buffer dereferences to a path. But asref does not give you a path. It just gives you a borrowed path buff. Which makes sense. I mean, it all makes sense, but it's not really, I mean, I don't know, depending on where you come from.
you have to know what you're looking for. I'm guessing, like if you know the structures, of course it makes sense. But freshly in, it's maybe a bit hard.
Yeah, it's just that you really have to know this deref thing. Like derefing is the most important. You know, this is happening automatically as well. This is why you can call path methods on a path buffer transparently, because it just derefs to path if the method you want is not on a path buff. So yeah, and the display here, by the way, have you seen that before?
No, actually, I would have thought that's something specific. Or is that something general to Rust?
Actually, it's something specific to path.
Okay.
I think we might not have talked about path yet. Maybe we do that for a moment, because it's kind of important. Because, or have you talked about OS strings? When we talked about strings?
No, we haven't actually.
Oh, okay, great. I left out a big topic, but paths are related. So this path buff here, what do you think the encoding is? I mean, if you print it now, you see it looks like ASCII, maybe UTF-8, but is that the encoding? The UTF-8, is that the encoding of every operating system out there in the world?
Probably not.
Or file system, right? It's not only operating system, it's file system specific what the encoding would be. And you're right, probably not. So also Rust does not just enforce UTF-8 and says I just don't work anywhere else, but it says path buffers are like OS strings. They are encoded in an unknown encoding. However, they are kept in an internal encoding that is close to the operating system they're in. So what does that mean? Maybe I'm not talking nonsense here. So you see, a path buff is really just a glorified OS string. And OS strings, they are encoded differently, even though they have no known encoding like UTF-8, no. But depending on the operating system, there may be some encoding present or not. So on Unix, it's no encoding specified bytes. On Windows, it's UTF-16 encoded stuff. So this is what makes handling path a bit tricky, because you can't ever just say, yeah, give me the bytes and I work with that. Well, that works on where you are probably working on, but on Windows, that does not work like this. And you have to convert stuff, you have to deal with it. And going back to why we have to do display, in order to display something, here we need UTF-8 encoded content. So what this does is to create a thin wrapper that contains the reference to the path itself. See, the path itself is borrowed. And then on the fly, as it's printed, it will re-encode the OS string in a way that can display in a UTF-8 encoded environment, which means that things that don't properly display, they will just be replaced by some character that tells you, oops, I can't do that. And this is why you have to do display, because without it, they don't actually implement display. This is what the squiggly line now wants to tell us. Yeah, and that's special. This is special about path. But it works. Cool. So we say we are in the repository GiG-03 right now. We can work with that. Now, yeah, what's next? What do you want to know?
I don't know. Can we count commits? So can we list contributors or stuff like that? Like finding out some more info about the repo.
Cool. Commits. Let's get all the commits. So we need some entry point. What's our entry point? Like which branch do we look at?
Oh, I see.
Entry point to the object graph is what I mean.
Is that also like how you say package specific, or do you just really talk about branches? So like the main branch or master branch?
Yeah, really just which branch to choose, so to say. How do we know where we get in? Like, your call.
I would say the main one then, just the
main one.
Yeah, main.
Main. Okay, but what if there is no main? Like, it's called main in GiG-03, but like could be master in many other repositories.
Oh, okay. So is that the head then? No.
Yeah, it's the head. It's the head. Okay. So we try to get the head. So what currently and probably in future as well is the case that Git repository isn't very much. It's just a bunch of paths that you know about, and it's a refs database, a refs store, and it's an object database, an object store. So I wonder, maybe I should rename this to objects or something, so that it matches a bit better, because now it's an object database, but it says it's a store. So maybe one day I decide what it wants to be. Usually it's called store. So I think it's refactoring to happen. But in the meantime, we work with what we have. So it gives you access to these things directly, which have a lower level API. So you can get everything done there, but you have to know more and do more. It might be less, it is most of the time less comfortable. So right now and in future, I believe, you want to convert a repository into a handle that is called easy to easy. And this easy thing, it's allowing, it's giving you access to additional functionality and additional methods that are higher level and are making everything nicer and more comfortable. So you can find objects to that, you can find references to that, and usually type only what you think makes sense. If it makes any sense what I just said. I mean, it's the highest level thing you want. And these easy handles, they usually keep them around. So now it's an intermediate handle here that is thrown away afterwards, but this contains some state, caches here and there. And this makes it not too expensive, but expensive enough to not want to just create this every time, right? So I should be able to do this and just rename my repository to now be an easy, and now I have the higher level interface and no access anymore to the previous one, even though it's still in there, right? So repo, it's still there as a reference, luckily, finally enough. And Rust is able to do that. Think about it. It looks like repo is now not available anymore, even though repo contains a borrowed repository. Like this contains a borrowed of this. But I don't have access to the original anymore, but it's still kind of there, and you can do that. So that's interesting. It doesn't destroy that just because you do this. It knows it has to keep it. So yeah. And here there's this method called head, and that's exactly what you want as the standard entry point to know what's currently checked out. But let's see if it's that easy. Okay, so first of all, this is giving you a result because it might not find a reference because it will search for head. You remember that file that knows which branch you're pointing at, and that might not exist. So usually that does exist. So here I wouldn't do anything special. I just get out of there or just question mark my way around this. And now let's see what we can do. Now we have a head kind. We can get the ID fully peeled object ID. So if you wanted to know which commit we are pointing to, we can do that like this. But it's an option. So it might simply not know which commit we are pointing at. Strange. Why would that be? Like, why does it not know what the ID is, generally?
I mean, you're reading the file, you say it cannot exist, but then could also mean that it's, I don't know, empty or stuff like that. That something is messed up with the ref.
But that would be invalid. Then it wouldn't be an option, then it would be an error somewhere.
Yeah.
So why? Initialize repository. Look, no commits yet, nothing to commit. It's this, I mean, if you look at this repository here, then we see it's a head like we know it. It points to refs heads main. But now as I go to refs heads, oh, there's no main. It's empty. There's nothing here in case you want to see this with your own eyes. So nothing there. And this is an unborn branch because there is no commit it could point to. And that's a very special state that you have to represent. And that's represented there in the types. So we have to deal with the unbornness of a repository, which happens exactly once. But your tool will deal with it properly. So we could say, once we have a commit, we should be able to do something with it into fully peeled ID. And then, okay, or else. Now I raise the option into an error. Because I actually, you know, in a new repository, we can't do much, right? So we want to bail out there. And I always forget, how do I make a quick and dirty error that just works? Hello. Let me try if that works. So is that now an error? Is a string an error by any chance? Can I use that? Oh, that's interesting. It did actually work. I'm amazed. Do I have to use a string or can I also just... Okay, that also works. Nice. Okay. Actually, I should probably just dock this here, maybe. View mode, dock. I don't really understand what the difference is between pinned and unpinned, but that should do. Okay. Now it's more easy to see. Cool, so that works. Bailing out on there are no commits, nothing to do here. Okay. That works, and we can actually put it to the test. Get init. And now we go target, debug. Do we have it here? Debug examples, stats. So now you see I just used the binary it builds directly, and it tells us we can't do anything here. Okay. How are you doing? Sorry, you're...
Yeah, no, all good. Makes sense.
It looked a bit like something doesn't make sense. Please tell me, because it doesn't always necessarily. I'm often confused. So now we should have, what do we have here? We have a fully peeled ID, which is an easy OID. And that's also interesting because it's now one of these easy types. And easy always means it's the highest level thing that always has a little bit more inside to make it really easy for you to operate with that. Mm-hmm. So now, since we have an entry point, we have a commit, I would hope we can use this. Yeah, right. This is giving us an option result. So now here I bail out again because in there is another potential error. Whatever can go wrong there, I don't care yet. So we have question mark, and now this thing should finally be something we can use. So we can get an object from it, which is interesting. We can get the commit object now, right? So we can have a commit ID, an object ID, and now say, give me the object. And that's the cool stuff that Git repository does for you that the plumbing crates do not. Because why would Git ref, the Git ref crate know anything about objects? It only knows about hashes, IDs, object IDs. That's the game. So these kind of, that is kind of luxury. That's what you want. That's what you get with Git repository, and that should be fast enough for you to use by default until you really have some performance problem, and then you optimize, or you think, hey, this could be faster maybe. Why do I need these wrappers that have more stuff inside, right? And this is, but only then you do it. So I do the same thing. It's not actually dog fooding, because dog food maybe is not that tasty. That is already pretty tasty. It's already a decent meal, even though it's not exactly complete. It's mostly rice, but you know, more sides are going to be added soon. Okay, so the object doesn't interest us, but we can use this to get the ancestors. And that looks like a traversal to me, which we need to do to count, right? There's nothing in Git that tells us what the total amount of commits would be. There's no object or commit count or something like that. You have to get some entry point, then you traverse. And that's the expensive part in Git always, because now you hit the object database and that has limits. I measure about 23,000 objects per second per core. And that's not that much if you think about it. Like, this adds up quickly, let's say. So multi-threading at some point is a must. However, here I don't think we can multi-thread much, because one commit is depending on the next, the next, the next. So we have to go in order. I don't know how to parallelize that. It's not a thing. So we have to do that by hand. I mean, by hand, just one by one on one core. Fine. Ancestors, and question mark out of there. Now we have an iterator, I believe. Not really. We have a platform. How do I call this? Do I call this platform already? No, I call it ancestors. Fair enough. So it's an ancestors platform. Internal jargon is it's platform, because this really just is an intermediate object that holds on to data that is needed for the duration of the iteration, so that it doesn't go away while you do this. This is it. This is why you now have to select again what you want to iterate. I think there's only all. So we want to iterate all commits. And you can imagine there's also there can be, I don't know where it is, or if it's actually implemented here. I don't know what that is. I think that's from somewhere else. That's something IntelliJ sees, but it's not GitOxide. This now allows you to also configure the iterator if there was something to configure, which there is, by the way. There's lots of options in libgit too, for example. Here, not that many yet, like nearly none. But the more you iterate, the more it becomes clear what you typically want. The easier it becomes to also then say, okay, we need this, we implement it. And then here's probably where you implement that, or on the lower level.
Like a filter, for example, or
yeah. I mean, it's an iterator, so you can do all the iterator things like filter, but there might be things that you really want to do on a lower level. And maybe that's here. I'd say most of the times that's probably in the internal ancestors iterator that gets created with all. So here we want to look at, so here it creates some iterator that creates this git traverse commit ancestor thing. And that is the actual traversal. And this is what you probably then configure differently, because there are some configuration options already. There's a predicate here that you can use. It's not yet exposed via Git repository though. So this thing can do more than you can do through Git repository. But yeah, this is the layering already. The difference between the plumbing below and the higher level access on top, which also means that unfortunately, to get that comfortable API, you kind of have to go again and implement certain pieces again, where you just alter a few things, but still kind of, right now at least, some boilerplate needed. This will be better. I'm working on making this kind of stuff much better, so this is less terrible, but somebody has to deal with it. So Git repository is the bastion for that, where all the nitty-gritty comes up at the very latest. Okay, anyway, now all ancestors, and we can count them. Commit. Sorry. Actually, we can also collect them for later. And call this commits. Num commits is commits.lang. Let's see if that works. If it compiles, it probably works. Okay, there we go. 5285. So that does also work. And now we have commits. I wonder what that is. I look, see that type. It's a vector of results of object IDs. So actually we didn't really deal with results or with errors at all. Because yes, traversal can fail, objects might not exist, something like that. If this would be a, how do you call it, a shallow clone, where there is not all commits available, then what happens? And I think the iteration would error out at this point, because it would try to load a commit that isn't there, and then you have an error. And this is what would be visible here. And right now we actually handle this nicely, because in a way we give you a reasonable number, even if it's a shallow clone. But to do it really properly, that count, we probably have to be very careful about our error handling here. And that's good for you, right? Like it's obvious by looking at the types that something can go wrong. But what I'm trying to say is doing this I probably miss one of these. This might also not be the right thing, because now if there is a shallow clone, for instance, we always report an error without providing any count, even though there are some commits that actually worked. But now we do handle errors, and now this one here is a vector of OIDs. That's nice. And each of these OIDs, they're kind of expensive. They have a reference to our easy shared. So they borrow our repo. So it's not only the 20-byte hash that is the object ID, or maybe more if it's SHA-256 soon, but it's also another pointer, which is at least on a 64-bit system, 8-byte. So quite some data there that you rack up just by doing this. So I'd say it's okay, because if you calculate how much that is, it's still relatively laughable for today's computers. But it's something you might just not want like that, because why? So there's always a way to detach, by the way, these easy objects. So easy OID, that's a good candidate for detaching it if you just want to store it all in a vector and do something with it. Because detaching just takes out the actual data and removes that easy handle, because you might just attach that later. So detach, attach to get rid of that. Because now also you have these OIDs, they do borrow something, right? So they're not standalone anymore. You can't just move that vector anywhere. It's bound, which might also not be what you want. So detaching is the thing that you do to do that. And it's also something, where you probably want to discover the API, like how do people use this? Should that be attached? Should that be detached? My default is now everything that you return here is usually attached automatically. So basically wrapped. But anyway, that's now a commit count. And that was relatively easy, I guess. One more thing, and then we might be done for today's session, basically. But we can continue working on this, because why not? It seems like something that can be built out quite nicely.
Absolutely.
commit message, maybe the last commit message, most recent commit message, something like that.
That sounds good.
Okay, most recent commit message. That's the first commit because the head points to the most recent commit. So the first item here in the iteration, the first item in the vector would be our most recent commit. If let sum most recent commit is commits 0, then can we oh, actually this is the safe version to do, right? So in case we have empty commits here, this would work fine. Because I handled the case that commits could be empty, but can commits be empty ever if you're here?
At that point, I don't think so, right? Because
we already bailed out.
Exactly.
And if something goes wrong here, we would also bail out. So we should have commits here. Yeah, and that's usually how I do it. If I really know that this shouldn't happen, I do an assertion here. You can differentiate between assertions and debug assertions. You know the difference?
Really? But I'm guessing that, I mean, one only show up in debug builds and the other one also in the full one.
Yeah. Which one is which?
Yes, and the debug assert will be in the debug build. Will only be in the debug build.
And this one
will be in both.
Yes, that's right. So that's the safest assert that you can do. That stays with you and will trigger panics if something isn't as it should be. Which also means that now we have a nice panic here that tells us, oh, commit should not be empty. Instead of here, where now I would have some panic because I tried to access index 0 of some array. So that's better. And you see how it tries to move out of commits, which it can't do. So I do have to tell it, no, don't move, just borrow. Thank you. Not mutably, just read only. Thank you. Okay, now that we've got that, we should be able to print something. Most recent commit message. Being most recent commit. Oh yeah, that's an object ID, right? So now I have to get the object. Probably there can be an error. And then, oh, interesting, look. Now I have an object, but it doesn't yet know that it's a commit. So now I have to cast it into a commit. Just tell it, look, it is a commit, trust me. So this is what toCommit does. So that will panic if this object is not a commit or if it couldn't be decoded. So just is a kind of an unsafe way to do things. We know it's a commit, but we also know that, yeah, we know it's a commit. We can be pretty sure it's a commit if we are here, I think, because we already traversed the commit history, and that means we have seen commits. But if something goes wrong with the decoding of that object, then this would panic too, right? So try to commit. Obtain a fully parsed commit whose fields reference our data buffer. And this one can have a conversion error, which deals with all the kind of issues that they are unexpected type or decode errors. So that's the safe way to do things. Try to commit and then we can error out. And now I think that's better, right? Because now we do error handling, but there might be cases when you really just know or you don't care because it's that kind of tool where it's just, you know, this quick, just do it tool. But that's not too much worse here, right? And to my mind, it's usually worth it to deal with errors and just set it up with a simple box like this if you have to. Okay. This box here, by the way, that should be anyhow. That's the top level application. Error handling and anyhow is just the thing you use, because this error will not look good once it's printed on the command line. It will look like a debug thing. But it works for us for now. Okay, so now finally I have the most recent commit object. I try to convert it into a commit, and if that works, I have access to the message, which is a B string. I think we talked about that briefly, what the difference is between a B string and a string. And the great thing about B strings is they will just do what path buff display does, or path display.
I was just about to ask, I mean, so they have that built in automatically, basically, this
Yes.
display method.
Yes. And if something can't print because the encoding is something very strange and it's not UTF-8 or not ASCII or anything, not ASCII or UTF-8, you could say, then you will just have a bunch of question marks there, I guess. All right. So here, most recent message, don't unnecessarily, yada, 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 yada. Okay, so that works as well. And that seems pretty straightforward to work with objects and references already. And yes, there was also quite some work to get it there, you know, to put all these layers on top. But also, it was nice to actually show that it is possible and that this actually works like intended. Because for a while I only had the plumbing crates and never really got around to Git repository. But I forced myself, and I do like the API. You know, it does work a bit funny in parts, but it's, I guess that's how it is. And working with objects also got much better over time, like the function or the method names to convert these, because I think they're relatively idiomatic. And yeah, I think it will be easy to remember too, but yeah, who knows? I'm certainly biased.
I think that's maybe one thing that's a bit, or that was a bit misleading at the beginning, that you called the commits or the most recent commits, right? It's like you said, it's not really a commit object yet. It's more like an ID or a ref that's pointing to one. I think that makes it a bit more clear what's going on. So you're getting the object from the ID, and then you're converting that to a commit object.
Yes, that's better. That's much better, true. It's just an object ID, which also says, probably want to call this commit IDs, and then it's clear. Yes, naming is still hard. Just imagine if you make an API, like how many times did I rename these methods? Oh, renaming is fortunately quite easy. Now I could rename it to foobar, but it takes a while to find good names, and then this goes through all the crates that there are, because then you have to keep it consistent. And yes, I did a lot of renaming in this project, that's for sure. And I hope that's the last time. Now I'm happy with it, but then fashion changes and I have to change it again. No, it's okay. No, it's good. Cool. But you see here you have a lot of information, but that's basically just what you get when you do git cat file head. Pretty. So you see that's pretty much the commit object as it is stored. That's the encoded commit objects. That's what Git Oxide parses for you to give you the parsed fields. And what it also does, and then I think we can close this session, it also returns a commit ref. So it's an object where all the items are parsed from some backing buffer and are just referencing that backing buffer. So you can imagine this message here is literally somebody pointing at a portion of that buffer, which is this. This is the whole buffer, which is stored somewhere. And this thing just knows, this is the message in that buffer. And it's always linked and tied to that buffer, right? So it's not a standalone object, it's not an owned object, it's a shared one. This is why it's a ref. And that's very, very efficient, you can imagine, because all you do is you decode the object, dump it into some buffer that you reuse, by the way, between the objects. And then you parse either everything or just parts of it at a time. So for example, you can also try to commit either. And then on this one, you have a few top level functions for stuff you typically want, or I typically wanted, like the tree ID. But you can then call next, and you get iterator items that go one by one through each of the fields that are available. So you can work yourself through to the message, which in this case doesn't save you any time because you still have to decode everything ahead. It's the last one. Yeah, it's pretty much the last one. So in this case, doesn't do so much, but if you're only interested in the tree, that saves time if you actually use a commit iterator and say give me the tree ID. And GiG-03 does that everywhere. So internally, these iterators are used exclusively to eke out that extra bit of performance where it really matters. And it really does show when you do that, and as opposed to parsing everything. And it really, I mean, I never did that, but it really would show, but many implementations do that, if you would own the whole object each time. So you decode the object into a buffer, and then you parse it and copy all the strings out into some own structure, like an own string or something like that. And that costs you a lot, of course, a lot of allocations and a lot of garbage if you're in one of these languages. And GiG-03 just doesn't do that. So it really is, even on the highest level, still as efficient as it possibly can be. And yeah, zero cost abstractions, Rust says. So ideally all that abstractionness goes away and it's still as efficient as it could be. Yeah, and that really shows it's faster than libgit2, and in many cases faster than Git, and also Git optimizes this, right? So everybody optimizes this already, but libgit2 probably not so much, even though to some extent they do. So that definitely something where GiG-03 is faster because of this. And whenever I say libgit2, by the way, with these comparisons, I can't really check or compare to Git because it doesn't have a library, right? It's hard to, you have to compare command line tools. You can't really compare certain things more specifically. So yeah, libgit2 isn't really the competitor for that because it's just not as optimized and as worked on as Git itself is. So it's not really that big of a deal to be faster than libgit2, I guess, but it's something. So yeah, that's how that works. And that could be it for today.
Awesome. Thank you very much.
Thank you, and thank you everybody who's watching. And I hope in the next session we will continue on this and you'll be watching again. Bye-bye.
Bye-bye.